Okay, so I think we start now. Coming to that previous problem, what we discussed in the previous class, I recalculated all those calculations what I have given. Maybe you maybe calculated that wrongly. So in both the way, I got the same answer, that is 11.97 in both the calculations. So if you have those calculations, you open your calculations. LE5, Purna, are you there?
Sir, yes, sir.
Okay, check your calculations. You said you are getting in second way of solving the problem. You said that you are getting 9 point something, right?
Yes, sir.
So what is the equation you consider there? You have to take your sigma A is equal to
SC by
SE divided by FS, right?
yes, sir.
What is sigma A? 140,361.92 divided by D cube. Andena? Sigma A is 140,361.92 divided by
Yes,
D
sir.
cube, which is equal to your SE is 163.
10
163.55. Right?
SC 189 వచ్చింది సార్ మాకు SC 189 వచ్చింది సార్
SE?
189 సార్.
Maybe you calculated that one is wrong. So what is your equation there? SM by SUT plus SA by SE is equal to 1. SM by SUT plus SA by
Yes,
SE
sir.
is equal to 1.
అదే
And your equation SA by SM is equal to 2. Second equation. Is
yes,
it
sir.
okay? So then,
Yes, sir. Yes, sir.
0.5, so if you substitute for SM as 0.5 SA, you will get 0.5 SA by 600 plus SA by 189.36 equal to 1. If you solve that equation, from that
Yes,
you will
sir.
get SA is equal to 163.55. What is the value of SA you got there? 163.55. What I
1
got.
minute,
So
sir.
I calculated it. Yeah, you do that. Not only you, remaining people also. Just try to check, verify that. So if you do the calculation wrongly, it goes to everybody like that. All our remaining people are sitting idle means without doing any calculation. They don't know what is going on also. So all of you need to use your calculators and data books. Then only you can understand.
163.40 వచ్చింది సార్.
SA is equal to 163.55. I got it. Okay,
63.40 వచ్చింది సార్.
Okay, no problem. So then you substitute that sigma A is equal to SA by factor of safety 2. That is sigma A is 140,361.92 divided by D cube is equal to 163 point, what I got, 55. 163.55 divided by 2. If I solve that equation, I'll get D is equal to 11.97. Exactly what I got in the previous approach. You check that now.
ఓకే సార్.
Yes, sir. 11.97.
So that means both approaches you got the same answer, right?
Yes, sir.
So that's what I observed also. You maybe in that class you said that it is around 9 point something. So you won't get that much difference, because whether you are following the first one or second one, we are doing the same thing. Only thing is, in case of first approach, what we did is, first we don't know whether the what you can say, life is infinite or not. So first we computed the sigma A value, then we compare that what I can value we got at sigma A value. We are comparing that one to SE. Then if sigma A is less than SC, you shall say it is infinite life. Here, directly we are taking the life is infinite and we are equating only SA to your sigma A. So either way, you need to get the same answer. So, okay, anyway, so that is about that previous problem. So now we'll take up
Okay, sir.
one more problem that is on shear stress. You note down this problem now. Okay, I'll read the problem, just you note down the problem, then we'll discuss the solution. So this problem is on shear stress, not on bending or axial stress. And this problem is also corresponding to the infinite life problem only. Okay, note it down. A transmission shaft, a transmission shaft of a cold drawn steel, a transmission shaft of a cold drawn steel, cold drawn steel, 27, 27 Mn2, 27 capital M, small n 2, 27 Mn2 within the brackets, SUT equal to 500 Newton per mm square and SYT equal to 300 Newton per mm square, comma, is subjected to a fluctuating torque, is subjected to a fluctuating torque which varies from minus 100 Newton meter, minus 100 Newton meter to plus 400 Newton meter, plus 400 Newton meter. A factor of safety is 2. The factor of safety is 2 and the expected reliability is 90%. The expected reliability is 90%. Full stop. Neglect the effect of stress concentration. Neglect the effect of stress concentration, comma, determine the diameter of the shaft. Determine the diameter of the shaft. Full stop. Assume the distortion energy theory of failure. Assume distortion energy theory of failure. Okay, so that is the problem. I will read again. A transmission shaft of cold drawn steel 27 mm2 within the brackets SUT equal to 500 Newton per mm square and SYT equal to 300 Newton per mm square is subjected to a fluctuating torque which varies from minus 100 Newton meter to plus 400 Newton meter. The factor of safety is 2 and the expected reliability is 90%. Neglecting the effect of stress concentration, determine the diameter of the shaft. Assume the distortion energy theory of failure. Okay, so that is the problem. So in this, so one important thing what you can consider is you have given an additional statement in the problem. So far in all our particular stress problems, we haven't talked about the static failure theories. We haven't used any static failure theories, but in this case, what he has specially mentioned, use or assume distortion energy theory of failure. So, do you have any idea why he has given this option? Why he mentioned that? Why he has given that statement in the problem? What is the reason for that? Or else, why we need to use this one? Where you can use it? Distortion energy theory? No response. Okay, right. See, so far whatever you solve the problems, all those problems are either corresponding to bending load or axial load. They are not corresponding to the shear stress. That's why I already mentioned in the beginning of the problem, this is the problem on torsional shear stress. So, in case of axial load or bending, your failure criteria are going to be either SUT or SYT. So, in all the problems, generally whenever a material is specified, they will give you the SUT value and SYT value. So, we don't need to use this distortion energy theory. But in case of the shear stress theory, in case of torsional shear stress, your SYT or SUT is not the failure criteria. In case of shear stress is there, your failure criteria should be, it's not SYT or SUT, it is SYS, that is yield strength in shear. Yield strength, SYT means yield strength in tension, ultimate strength in tension. So we are not talking about the tension. So here we have a shear stress or shear load, torsional shear load. So therefore, you need to compute what is your SYS. That is yield strength in shear. So yield strength in shear is not a material property like your SYT and SUT. You will get SYT or SUT from your tension test, simple tension test, whereas you won't get this one. So because your SYT and SUTs are the material properties, but yield strength in shear is not a material property, you need to use the empirical relation to find out what is SYS. To find this yield strength in shear, we have two static failure theories, what we discussed in the earlier classes. Those are either you can use maximum shear stress theory or you can use distortion energy theory only. So again, these two theories are predicting the yield strength in shear is differently. If you use maximum shear stress theory, according to your maximum shear stress theory, your SYS is nothing but 0.5 SYT. According to maximum shear stress theory, SYS is equal to 0.5 SYT. This is we already derived these equations. So I am again repeating those things. So, or else if you use this distortion energy theory, then according to distortion energy theory, your SYS is 0.577 SYT. So, either you can use this or this to solve the problem instead of SYT. So, whatever equation, Goodman line equation, whatever you written, that is sigma m by SUT plus sigma a by SE is equal to 1. You cannot use that equation here. Sigma stands for the normal stresses. Here you have a shear stress. So if you want to write the Goodman equation for a shear stress, it should be tau m divided by SYS plus tau A by SE is equal to 1. So how to use like this? That means your SYS is SYT will be replaced by SYS because it is a shear stress. So this is the important point you need to remember when you switch from normal stress values to the shear stress. Don't take blindly in the equation SE, SYT. See, SE is same here, you will get only SE only, but here in place of SYT, you will get SYS or SUT, in place of SUT, you will get it as SYS. So that is the important point we need to remember. Of course, in this for this problem specifically, you mentioned that use distortion energy theory. If not, you can take any one of these two. If it doesn't mention anything about this one, you can use any one of those two methods. Either you can use maximum normal stress theory, or you can use maximum shear stress theory, or you can use distortion energy theory. So now, for this case, we use distortion energy theory because that is mentioned in the problem itself. So therefore, it is 0.577. Your SYT is 300. So now I'll get this one as SYS. Okay, right. So that is the reason. So only this is the why he has given is to estimate this SYS. He has given this condition. You need to follow distortion energy theory. Right. So after that, the remaining procedure is as per our modified Goodman's diagram. So in case of torsional shear stress, what is your modified Goodman diagram? Your modified Goodman diagram will look like this. It is not same for the axial and bending loads. So it is different from bending stress or normal stress. If you take normal stress curve, the normal stress curve or modified Goodman diagram is different. For shear stress, it is different. Why it is different? Because for tau m, so here you can see it is a horizontal line. So that means the mean shear stress is not going to have any influence on your SE. This is your SE. So SE is constant, whatever may be the tau m value, up to certain value of this tau m. So this is independent of your tau m. That means it is not going to be influenced by this mean shear stress. Only it is a function of the amplitude shear stress. So therefore, in case of whenever there is a problem on torsional shear stress, you need to take your design criteria. That's what we already discussed in the previous class also. Maybe not the previous, before that class. So only SE is going to be the failure criteria if you want to consider the fatigue load. Or if you want to calculate the static failure, then you have to consider tau m as well as tau a. So now, coming to this problem now, if I want to solve this problem, first I need to construct this one. So this is the modified Goodman diagram. We already know this. So we already discussed this also. So then you need to construct the load line. Load line is something like this. Here this is theta. So this is your design point. So X, let us say X is the design point for you. So now you need to identify what is the value of this X. So simply it is only SE only. The design point, your failure criteria is only SE. So here it is immediate because it is a straight line. So now you have to estimate what is SE value. You need to estimate what is SE value. So once you have SE value, then your design equation is your tau A is equal to SE or SE by Fs if factor of safety is given. So this is going to be the design equation for a fluctuating load. Or else if I want to consider static failure also, you need to estimate what is your tau max. Tau max is nothing but tau A plus tau m, which should be equal to, this should be equal to your SYS, just now what we calculated, SYS divided by Fs. So you need to use these two equations to solve this particular problem. So now to proceed further, first you need to estimate what is SE. You need to estimate what is SE. So for that we have a standard formula for SE. What is the formula for SE? SE is equal to Ka, Kb Kc, Kd, Ke, Kf into Se dash. So we need to compute what are all these parameters: Ka, Kb, Kc, Kd, Ke, Kf. Of course, in most of the cases, we'll take Kd and Kf is 1. So they won't give anything about temperature. Suppose if it is given intentionally, then you need to consider. Or else we'll take Kd is 1, Kf is also 1. So then what is the remaining thing is, you need to find out what is surface finish factor, what is size factor, what is load factor, and what is the reliability factor. So now identify this. So what is the type of surface he has given? It is a cold drawn surface or cold drawn steel. So for steel, you have your SC dash is nothing but 0.5 SUT. So that means SUT is 500, your SC dash will become 250 MPa. Then Ka is nothing but A into SUT to the power B. In case of cold drawn, your A is 4.51, SUT given as 500 to the power minus 0.265. If you compute this, you will get your Ka as 0.8. Let me check my calculation also.
0.868, sir.
0.866. Yes, 0.868.
68.
Then Kb, size factor. So here we have to compute the diameter. So we don't know what is the value of what is the size of the shaft. So then what I have to do is, again what I will do here is, I will assume the diameter lies within the range 7.5 mm to 50 mm, so that I can take this one as 0.85. Kb as 0.85. Then Kc, that is the load factor. So load factor is going to be 1 when it is a bending load. It is equal to 0.85 when the load is axial load, and it is equal to 0.59 or 0.597 when it is a shear, direct shear or torsional shear. So this problem is on, see, he has given a torsional torque, T minimum and T maximum. So it is the problem now is corresponding to the torsional shear stress. So therefore, what is the load factor for that? Load factor is 0.59 or 597. Then, like already told, Kd is 1, Kf is 1, and what about Ke? The expected reliability is 90%. For 90% of expected reliability, our K is 0.897. So all these things you have to pick from the data book only. Or else, if the data is not there in the data book, you need to remember the values. There is no other way of solving the problem. Then, once I know all these things, then I can compute SE. SE is equal to K is 0.868 multiplied by KB is 0.85 multiplied by KC is 0.59 multiplied by KD is 1, KE is 0.897 and KF is 1 multiplied by our SC dash is 250. So now you tell me what is this SC value?
97.61, sir.
It is 97.61.
61.
97.61 MPa. Okay, so now in this equation, I got now SC value. Fs is already given to me. Now I have to compute only tau A. So for tau A, what you have to do is you have to calculate what is T minimum. He has given T minimum and T maximum. So I have to calculate only tau A. So for tau A means I need to calculate what is the TA, that is amplitude of the torque. So how I can calculate that? TA is equal to T max minus T minimum divided by 2. So which is equal to T max is given as 400. Of course, see here it is in Newton meter. But your all other values are in terms of Newton mm square. So I need to convert this one is also into mm. So if I do that, I'll get it is 10 cube. 400 into 10 cube Newton mm. So this will become, if I multiply this one by 10 cube, it will become Newton mm. So 1 meter is equal to 10 power 3 mm. So I need to multiply that one by 10 power 3. So your T max is minus 400 into, 400 into 10 cube, then minus T minimum. T minimum is minus 100 Newton meters. So this minus of minus, you will get it as plus 100 into 10 cube divided by 2. So which is going to be 250 into 10 cube Newton mm. 250 into 250 into 10 cube Newton mm. So this is my amplitude torque. I want to compute tau A. What is the formula for tau A? You need to use the torsion equation. Tau is nothing but T by Zp, where Zp is the polar section modulus. So here TA divided by Zp. What is TA? We got TA as 250 into 10 cube. See here, for this tau A, I am not applying fatigue concentration factor Kf. Why I am not considering that Kf in this problem? If you read the problem, in the problem itself, it clearly said that there is no stress concentration effect. So that means stress concentration is not there in this particular shaft. So that's why I am not taking Kf value. Suppose if he has given the Kf value or not sensitive factor, or if the same shaft is made of a step, 2 steps, then I have to compute Kf value. First Kt, then I have to identify what is the not sensitive factor Q, then I have to find out what is Kf, then I need to apply that Kf to this tau A. In this problem, since there is no stress concentration, means your Kf is equal to 1. That's it. Or your Q is 0. Q is, there is no notch. Notch sensitive is 0. If notch sensitive Q is 0, your Kf will become only 1. So we'll use the same thing here. So that's why I'm not going to use any stress concentration factor in this problem. So clearly you mentioned that there is no stress concentration in the divided by polar section modulus is nothing but 5 by 6, 5 by 16 d cube, where d is the diameter of the shaft in mm. So polar section modulus for a circular shaft, it is nothing but 5 by 16 into d cube. Of course, we are assuming it is a solid shaft. It's not a hollow shaft. So that's it. I have equation for tau. So while equating that, you need to consider this Fs also. So that's why our equation is tau A is equal to Se by Fs. Now, if I substitute those values into that, I can solve for d value. So I'll rub off this. Okay. So then, from this equation, what I'm getting is tau A is nothing but 16 into 250 into 10 cube divided by 5 into d cube. So I brought this 16 to the numerator. That is the only thing I did, done it there. Is equal to your SE is 97.61 divided by factor of safety is 2. So now solve this, you'll get, from this you'll get d value. So tell me what is the value of d?
29.65 వచ్చింది సార్.
Ah,
Sir,
29.65.
29.65.
40?
29, sir.
29.65.
29.65.
65.
Okay, right. So 29.65 mm. So that is the answer. But it is not completed. The problem is not completed. Why? Because why it is not completed here? I check for only fatty failure. I haven't checked for yielding is taking place or not. So to find that whether the yielding is taking place or not, so I need to compute what is tau max. The second equation what I written here. So I need to consider this one also. So failure in the sense, a failure may be either it may be a static failure or it may be a fatigue failure. So in order to avoid fatigue failure, your diameter is 10.65 or approximately equal to 30 mm. But I need to check if I take these 30, whether it is going to fail by yielding or not. I need to check that also. So to do that, I have to compute what is tau A plus tau M. So just now here we calculated tau A. Then what is the formula for our tau M? That is mean torque is nothing but tau M Tm divided by Zp. Tm divided by Zp. So which is equal to your mean torque. Mean torque is nothing but T max plus T minimum divided by 2. T max is 400 plus of minus 100. So 400 minus 100 divided by 2. It
150, sir.
is 150.
Into
150
10
into 10
cubes.
cube. 150 into 10 cube Newton mm divided by 5 by 16 into d cube. So now you have tau m and tau a. Then you add those two, tau m plus tau a. So you tell me what is the value you got it. If you add these two, that means your tau max is equal to tau a plus tau m, which is, you tell me. So what is the value of the sum of those two? What is the value? Tau A plus tau M. You will get, of course, you will get in terms of D only, D cube only. So 16 into 250 into 10 cube divided by 5D cube, 16 into 150 into 10 cube divided by 5D cube. Endamma, value on the tau max value?
Two zero three 2037.183 into 10 cube by d
అర్థం
cube.
కావట్లేదు అని మైక్ క్లారిటీ లేదు నువ్వు చెప్పేది అర్థం కాదు నాకు మళ్ళా సార్ చెప్పు క్లారిటీగా స్లోగా చెప్పు
2037. 2037. 2037, sir. 2037. 0.183. 0.183.
into 10 cube.
0.183 into 10 cube, sir.
0.183 into 10 cube divided by d cube.
Yes, sir.
This should be equal to your SYS by FS. What is SYS? Now you have to use this discharge energy theory. So SYS is nothing but 0.577 into 300. What is this value?
173.1, sir.
Ah,
173.1.
okay, 173.9
1.
MPa. So here also you need to substitute the same 173.9 divided by factor of safety 2. So now you solve this equation. From this you get one more value for D.
28.65.
1 minute. I'll also done that. I'll check it. 28.65.
65, sir.
28.65 mm. So now I got two values. Again, we need to pick one value from these two, which is suitable for the given shaft. So you have to pick this D value, that is 29.65, which is equal to 30 mm. Why not this? Because this is a smaller value when compared to this. If I pick this one, the shaft is safe for yielding, against yielding, but it is going to fail under fluctuating load. Because to avoid the fatigue failure, you need to have at least the diameter should be 29.65. If I take it as 28.65, the shaft will fail by fatigue. So to avoid both static failure as well as fatigue failure, I need to choose the largest value of those two. So which is going to be 29.65 mm, or approximately it is equal to 30 mm. So that is the answer for the problem. So whenever you have a torsional shear stress or shear stress is there, now you need to solve the problem like this. Right? Is it clear? Or any doubt in this? If it is clear, we'll move on to the another problem which is on. Now next problem we'll consider the problem is on finite life, not infinite life. So far these two problems, whatever we discussed, they are on infinite life. So if you take the diameter of the shaft as 30 mm, it can withstand 10 power 6 or more number of stress cycles. So we can say it is infinite life. So whereas maybe in the next problem it is on finite life. So we'll consider that also. If it is over, then we can move on to the next problem. Is it over or not? Or if you have any doubt, then you can ask, no issue. If you have any doubt in this one, you can ask. So that after clarifying your doubt only, we'll move on to the next problem. Okay, no one is responding. Don't know whether you are following it or not. Maybe I'll take it as granted. You know everything. Okay, then note down the next problem. A polished steel bar, a 1 minute, I'll change that problem. I don't, okay, yeah, we'll take that only. No problem, take it. A polished steel bar, a polished steel bar is subjected to axial tensile force, is subjected to axial tensile force, axial tensile force that varies from 0 to P max, that varies from 0 to P max. So here the load is varying from 0 to maximum value. So that means it is a repeated kind of load. Even though it is a repeated kind of load, still it is a fluctuating load. It comes under only fluctuating load because sigma mean is not 0 even in case of repeated load. Okay, so the axial tensile force that varies from 0 to P max, full stop. It has a groove, it has a groove two mm deep, it has a groove 2 mm deep and having a radius of 3 mm and having a radius of 2 mm, sorry 3 mm, not 2 mm, 3 mm. It has a groove 2 mm deep and having a radius of 3 mm. Full stop. The theoretical stress concentration factor, the theoretical stress concentration factor, the theoretical stress concentration factor and the notch sensitivity factor and the notch sensitivity factor at the groove and the notch sensitivity factor at the groove are 1.8 and 0.95 respectively. 1.8 and 0.95 respectively. Full stop. The outer diameter of the bar is 30 mm. The outer diameter of the bar is 30 mm. Full stop. The ultimate tensile strength of the bar is 1250 MPa. The ultimate tensile strength of the bar is 1250 MPa. Full stop. The endurance limit, the endurance limit in reverse bending is 600 MPa. The endurance limit in reverse bending is 600 MPa. Full stop. Find the maximum force. Find the maximum force that the bar can carry. Find the maximum force that the bar can carry for 10 power 5 cycles. For 10 power 5 cycles with 90% reliability. For 10 power 5 cycles with 90% reliability. Okay, that is the problem. I'll read it again. A polished steel bar is subjected to axial tensile force that varies from 0 to P max. It has a groove 2 mm deep and having a radius of 3 mm. The theoretical stress concentration factor and the notch sensitivity factor at the groove are 1.8 and 0.95 respectively. The outer diameter of the bar is 30 mm. The ultimate tensile strength of the bar is 1250 MPa. The endurance limit in reverse bending is 600 MPa. Find the maximum force that the bar can carry for 10 power 5 cycles with 90% reliability. Okay, so that is the problem. So in the problem itself, he has given that it is a finite life problem. Why? How I can say it is a finite life problem? Mr. Balasubramaniam, are you there in the class?
10 power 5 cycles అని ఇచ్చారు కదా సార్.
Okay, I am asking Balasubramaniam, 38 or 39, something. Roll number 38, I think. 38 or 39. Is he there in the class or not? So whenever I ask a question, simply you will disconnect from the class, saying that there is a network problem. Like that, you will say. He is there, but he is not responding. His name is there here. 38, he is attending the class, but he won't respond. Whenever I call, he won't respond. Are you there or not? If you are not there, then where is joining the class? Who is his friend? ఎవరు ఫ్రెండ్ ఈడు? బాలసుబ్రహ్మణ్యం. ఈ ఫ్రెండ్ ఎవరు? క్లోజ్ ఫ్రెండ్ ఎవడు? ఈడు అట్లేనా?
39 సార్, శంకర్.
39 సాయి శంకరన్.
సార్.
ఉండమ్మా, అసలు ఇటు క్లాస్ అటెండ్ అవుతుందా?
అవుతున్నాడు సార్.
మరి ఏంటి రెస్పాండ్ అవ్వడు ఏంటి?
అంటే నిన్నటి నుండి ఫీవర్ వచ్చిందని చెప్పాడు సార్, హెడేక్ గా ఉందని చెప్పాడు.
ఫీవర్ అయితే వాడు లాగిన్ అవ్వడం ఎందుకోడు? నాకు అర్థం కాదు.
ఏమో సార్ మరి.
కరెక్ట్ గా నేను అడిగిన రోజు ఫీవర్ వస్తుంది అంతేనా?
నిన్న ఈవినింగ్ నుండి అన్నాడు సార్, హెడేక్ గా ఉంది బాగా అన్నాడు.
లాస్ట్ సాటర్డే క్లాస్ లో కూడా అంతే కదా, ఆ రోజు కూడా నేను పిలిస్తే పలకలేదు వాడు. ఆ రోజు కూడా ఫీవర్ వచ్చిందా?
ఏమో సార్, నిన్న మాత్రం అన్నాడు సార్ నాతో, బాగాలేదు అన్నాడు.
లేదు సార్, ఉన్నా సార్ క్లాస్ లోనే.
ఇప్పుడు నిద్రపోతున్నావా? ఇప్పుడే మెలకు వచ్చిందా?
లేదు సార్, లేదు సార్, సాటర్డే పలికా సార్, మేము పిలిస్తే మీకు వినపడలేదు.
ఎక్కడ పలికావరా? పలికితే ఇక్కడ రావాలిగా, ఇప్పుడు వచ్చింది.
అదే సార్, మీకు వినపడలేదు, టెక్నికల్ ప్రాబ్లం అని చెప్పి లింక్ నిన్న లింక్ క్లోజ్ చేసి వేరే లింక్ పెట్టారు కదా సార్ సాటర్డే మీరు.
సరే, ఫీవర్ ఉందా లేదా ఇప్పుడు?
అప్పుడు పలికా సార్, పిలిచిన వెంటనే ఫస్ట్ నన్నే పిలిచారు. ఉంది సార్.
ఫీవర్ ఉందా?
ఉంది సార్.
ఫీవర్ లోనే అటెండ్ అవుతున్నా క్లాసులకి? ఫాలో అవుతున్నా అన్ని క్లాసులు?
ఫాలో అవుతున్నా సార్.
సో చెప్పు మరి, ఈ ప్రాబ్లం అంటే ఫైనైట్ లైఫ్ ప్రాబ్లం అంట, నువ్వు ఎందుకో చెప్పగలవా? ఇన్ఫైనైట్ లైఫ్ ఎప్పుడు అంటావు? ఫైనైట్ లైఫ్ అని ఎప్పుడు అంటావు? సరే వదిలే, మనకి అటాక్ రాదులే, ఎందుకు నేను పట్టుకున్న టైం వేస్ట్. ఉదయ్ కిరణ్ 25.
సార్
చెప్పమ్మా, ఎందుకన్నా ఈ ప్రాబ్లం ఫైనైట్ లైఫ్ ప్రాబ్లం అన్నావు ఎందుకు?
1 minute సార్ చెప్తాను.
1 minute?
ఇన్ఫైనైట్ అంటే యాంప్లిట్యూడ్ ఆఫ్ సిగ్మా స్ట్రెస్ లెస్ దాన్ ఎండ్యూరెన్స్ కంటే ఉంటే కనుక ఇన్ఫైనైట్ సైకిల్ అంటాం సార్.
అవునా?
అవును సార్. 10⁻³ నుంచి 10⁻0 దాకా ఉంటే కనుక లిమిటెడ్ అంటాం సార్ దాన్ని.
ఏదైతే 10⁻³ నుంచి
10⁻0 సైకిల్ 10⁻0 అనుకోండి సార్.
10⁻0 అంటే 1 అంతేనా?
అవును సార్.
1 నుంచి 1000 వరకు ఉంటే
లిమిటెడ్ అంటారు సార్.
అన్లిమిటెడ్?
లిమిటెడ్ సార్. ఇన్ఫైనైట్ అయితేనేమో
తర్వాత
ఇన్ఫైనైట్ అయితేనేమో స్ట్రెస్ అనేది ఎండ్యూరెన్స్ స్ట్రెంత్ కన్నా లెస్ దాన్ ఉండాలి సార్.
మరి ఈ ప్రాబ్లం ఎందుకు అంటున్నావు? ఈ ఫైనైట్ అని ఈ ప్రాబ్లం ఎందుకు అంటున్నావు చెప్పలేదు. నేను అడిగిన క్వశ్చన్కి నువ్వు ఆన్సర్ చెప్పలేదు. ఏదో నీ నోట్బుక్ లో ఏదో చదువుతున్నావు, ఏదో రాసావు, అదేదో చదువుతున్నావు, అది ఓకే, దట్స్ ఓకే. బట్ ఈ ప్రాబ్లం అంటే ఫైనైట్ లైఫ్ ప్రాబ్లం అని ఎందుకు అంటున్నాం మనం?
ఏమో సార్, ఏమో సార్, తెలియదు సార్.
తెలీదా? ఇప్పుడు ఏంటంటున్నారు రోజు ఇన్ని క్లాసులు? 10⁻6 సైకిల్స్ అంతకంటే ఎక్కువ ఉంటే ఏమంటాం? వాట్ ఇట్ ఈస్, ఫైనైట్ ఆర్ ఇన్ఫైనైట్? వాడు చెప్పాడు కూడా, LE5 ఆన్సర్ కూడా చెప్పాడు. నువ్వు అది కూడా ఇంట్లో ఎక్కడో ఉన్నావు, నువ్వు అయితే ఏదో లోకంలో. నేను క్వశ్చన్ అడిగినా వాడు ఆన్సర్ చెప్పాడు. ప్రాబ్లంలో ఎన్ని సైకిల్స్ అని ఇచ్చాడు రా? వాట్ ఈస్ ద లైఫ్ ఆఫ్ ద కాంపోనెంట్ ఈస్ రిక్వైర్డ్?
10⁻5 అని ఇచ్చాడు సార్.
10⁻5 అని ఇచ్చాడు. సో దాన్ని నేను ఫైనైట్ అంటున్నా. సో ఇన్ఫైనైట్ అంటే ఏంటి? ఇప్పుడు తెలిస్తే ఫైనైట్ కాదో చెప్పవచ్చు, అంతేనా? ఇఫ్ ద నంబర్ ఆఫ్ సైకిల్స్ ఈస్ మోర్ దాన్ 10⁻6 సైకిల్స్, దెన్ వి సే ఇట్ ఈస్ ఇన్ఫైనైట్ లైఫ్. 10⁻6 కంటే ఎక్కువ సైకిల్స్ ఉంటే వీల్ కాల్ ఇట్ యాజ్ ఇన్ఫైనైట్ లైఫ్. 10⁻6 కంటే తక్కువ ఉంటే వీల్ కాల్ ఇట్ యాజ్ ఫైనైట్ లైఫ్. సో ఇప్పుడు ఫైనైటా ఇన్ఫైనైటా ఈ ప్రాబ్లం? ఏంటి ఇంకా ఆలోచిస్తున్నావు? నాకు అర్థం కాలేదు. దీంట్లో ఎన్ని ఇచ్చారా?
ఫైనైట్.
ఎందుకు?
ఫైనైట్
10⁻5 ఇచ్చాడు అంతేనా?
అవును సార్.
So which is less than 10 power 6. 10 power 6 కంటే తక్కువ కాదా?
అవును సార్, తక్కువే సార్.
Then it is, that's why it is called finite life problem. So previous problem లో ఇవే మెన్షన్ చేయలేదు. So therefore we design for infinite life. అలానే previous problem లో కూడా you want to design a shaft for let us say 10 power 4 cycles or something like 90,000 cycles. Then you can say they are also finite life problems. But in those problems, it doesn't mention anything about the number of cycles it has to withstand, so that we are designing those components for infinite life. Okay? Anyway, so we have 5 minutes time only. So we cannot complete this, but only thing is, we'll discuss and next class we'll try to solve this problem. Or else, what I'll do is, I'll tell you the procedure and I'll see how many of you able to solve this. Okay? Right. So, we'll discuss the procedure and I'll leave it to you. Anyway, you need to upload all these things in your classroom so that I can verify that. So, this may be one kind of check also, whether you are following the class or not. I can understand that also from your response. Right. So, in this problem, it is a finite life problem. So, wherever you have a finite life problem, first you need to estimate. Now your SE is not going to the failure criteria. If you take that your SN curve, in case of SN curve, only your SE is the failure criteria for infinite life. Like that what Udayakarani is told, if the amplitude stress magnitude is less than your SE value, you can say it is a infinite life. So we'll design based on SE. This is corresponding to SE on your SN curve. This is log N and this is log SF. So your SA falls within this region, then you can say the component will have infinite life. But here clearly said that it is a finite life problem. That means he has given 10 power 5 cycles. Okay, if I clearly draw this diagram, it looks like this. So log N, here log SF. So here I'll start with 3 and 6, 10 power 6 corresponding to your SE value. So I can join this line something like this. Here this point is corresponding to your SE and this point corresponding to 0.9 SUD. Now in the problem itself, it has given the life is 10 power 5 cycles. So that means if I take a log for that, log 10 of 10 power 5, I'll get is only 5. So now this is the my point on the horizontal axis, life axis. If I extend that onto the failure curve here, I'll get some intersection point. Now if I'm able to find out what is the fatigue strength of that one, see here, this is your SE. And this is the actual required fatigue strength for the component to have 10 power 5 cycles. So that means your SE is not the design criteria now. So SF, you need to estimate first what is SF. You need to estimate what is SF. Then based on that SF only you can design the component. So again, but the thing here is to estimate this SF, you need to have this failure curve equation. So that means you have to estimate what is SE value. Then you have to estimate, you have to identify this point. Then using this SN curve only you can find out SF value. So that means still even though your design criteria is not SE, to estimate this SF value, you required SE and these points on this curve. So only thing is, I want to find what is this SF value. To do that, here I should know what is this distance. If I know this distance, then I can find out the SF from that SN curve. To estimate that, you require this value, SE value and 0.9 SUT value. Of course, they are in logarithmic values. So then from that, you find out what is SF value. Once you know the SF value, then you can use this SF as your failure criteria. You have to use your SF as a failure criteria. So then, now onwards, your equation is, since we said it is a axial force, axial force corresponding to a normal stress. Axial force will create a normal stress. So here now you have to take your equation is something like this. Instead of SE, now you have to take SF. Sigma A by SF plus sigma M by SUT is equal to 1 by Fs. And also the other equation is your sigma A by sigma M is equal to tan theta. That is the load ratio. So from these two you will get the relation. So this is one relation you are going to get. So this is another equation. So only thing here you need to remember is here instead of SE you need to use SF. That is the important point you need to remember. So once from this SN curve you try to estimate SF. We already solved so many problems are like this on SN curve. So we know how to do this problem. Then you take this equation and you try to solve this problem. So in this, only unknown is going to be your P max. The unknown is only P max only. He said the load is varying from 0 to P max. Minimum value is given, maximum value is unknown. Minimum value is 0, maximum value is P max only. We'll take it as P max only and we'll try to find out what is those values. So of course, in this particular problem, you will get your sigma A is equal to sigma M. Why? Because your P minimum is 0. Sigma amplitude is nothing but P max minus P minimum divided by 2 into area, cross-section area. P by A is the area, stress formula for stress, load by area. So here I have to take it as plus or minus. Minus is for amplitude stress, plus is for mean stress. Anyway, since it is 0, you get only P max by 2 times A. Your sigma A is equal to sigma M, which is equal to P max by 2A. A is nothing but the area of the cross section. So diameter is already given. So you can calculate the area. So everything is known here. Except this P max. You take this and substitute into this. From this SN diagram, you calculated SF. SUD is already given. So sigma A and sigma M already known to you here. You substitute all those things. If factor of safety is given, consider that also. And try to solve this problem. But before that, here for the sigma A and sigma M, don't forget to apply this KF also. You need to apply fatigue stress concentration factor also. So in this particular problem, especially no need to use the data book. He has already given the values. KT is 1.8 and Q is 0.95. Right away using those values, you can calculate KF also. No need to use the data book for the finding out KT value. Whatever he has given in the problem, use that KT value. So right, so like this you can solve the problem. So you substitute P max in this all these things, only unknown is P max. If you solve those equations, you will get the P max value also. So that is the answer for the given problem. So I hope you can solve this problem. I'll see how many of you are going to solve this. Maybe I've given up to today evening. I kept a time limit up to 5 o'clock. I'll see how many of you solve this problem and upload this to your classroom. Okay, I'll stop at this point today. Maybe we'll continue in the next class. And also one more announcement is, next class you have e-transfer, not maybe as per your timetable you may have other class, but try to join in the e-transfer class for next one.